Hello students, good morning all of you. Today we will complete the rest of our chapter, that is waves. Now we have seen progressive waves as well as sound waves, that are the transverse waves and longitudinal waves. Now actually the chapter is same, but in some publications it is divided into two parts, like light waves and sound waves, or string waves and sound waves. Okay, but it is the same. Okay, so we have seen the differences between the progressive waves, the types of progressive waves, that are transverse wave and longitudinal wave, and we have seen the differences between these two kinds of waves. Now we are going to see the transverse wave. So first of all, we revise. We have seen the velocity, that is under root T by mu for string wave. String wave. This is the velocity. So what is this T? T is for tension in the string. Now this is string. Okay, and mu is mass per unit length. Which is in kg per meter. Mu is mass per unit length. So this is the formula for velocity of string wave, that is the transverse waves. Now in case of sound wave, see, in case of sound wave, the velocity is under root P by rho, where P is the pressure and rho is the density of medium. Because we have seen that sound wave requires a medium for its propagation, but in case of string wave or in case of light wave, it does not require any medium for its propagation. That is, the velocity of light wave is maximum in vacuum and velocity of sound wave is maximum in solid. So this is sound wave, velocity for sound wave. Now we will see, as per the unit, it is correct or not. See, what is the unit of pressure? Pressure upon density. Pressure is Newton per meter square and density is kg per meter cube. Okay. Now Newton is mass into acceleration. Newton can be written as kg meter per second square. This is mass into acceleration upon this meter square. Force upon area is the pressure. Newton upon meter square. Now kg per meter cube. Now see here, kg will get cancelled. Now this meter square will cancel out this meter cube. 1 meter will remain. This meter goes to numerator. It will be meter square upon second square. Meter square upon second square is nothing but velocity square. So when you substitute this meter square upon second square inside the root, it will be meter per second out of the root. Okay. Now come here. This is mu and tension. Tension is in Newton and mu is in kg per meter. Now if you see, tension per mass per unit length, tension is in Newton and mu is kg per meter. This Newton can be written as mass into acceleration, kg meter per second square upon kg per meter. Kg will get cancelled. This meter will goes to numerator. It will be meter square per second square. Now meter square per second square is the unit of velocity, the square. So if I substitute this meter square per second square inside the root, out of the root it will be meter per second. So this is the velocity for string wave when string is tied between the two ends, and this is the velocity for sound wave. Now why string wave is taken as light wave? Because light wave and string wave both are transverse. Transverse means direction of vibration is perpendicular to direction of propagation. Now here आहे direction of propagation, light wave इकडे जात असेल और string इकडे जात असेल, then it will vibrate in the perpendicular directions. Okay. Now, again I am revising a few concepts like the progressive wave is doubly periodic. We have seen it is periodic in time as well as periodic in space or periodic in distance. I have given you example of city bus. Like the same phenomena will repeat after equal interval of time on a particular at a particular bus stop and with equal interval of time, that is the frequency of bus is periodic or the arrival of bus is periodic, and the same phenomena will repeat after equal interval of distance. Okay, that's why the wave is periodic in space as well as periodic in time. So we can say that progressive wave is doubly periodic. So we can write the equation of progressive wave as y is equal to a sine omega t minus kx. Now this minus kx or plus kx. Minus is when the wave is traveling in the plus x direction. So remember the thing, when wave is traveling in positive x direction, then the equation will be y is equal to a sine omega t minus kx. That is, this wave is traveling in this direction. Now suppose when or if the wave is traveling in negative x direction, then the equation will be y is equal to a sine omega t plus kx. So when it is traveling in positive x direction, here it will be negative sign. When it is traveling in the negative x direction, the sign will be positive. Like this wave is traveling in this direction. इकडे जात असेल तर पॉझिटिव्ह निगेटिव्ह घेणार, इकडे जात असेल तर आपण पॉझिटिव्ह घेणार आहे. ओके. Now, when we superimpose two waves at a point by principle of superposition. Now, first of all, we see what is principle of superposition of waves. Principle of superposition of waves. Now, what is superposition principle? Let's see, when two waves arrive at a point simultaneously, this is the wave 1, this is the second wave. When these two waves arrive at a single point simultaneously, then the resultant amplitude of the wave is vector sum of the individual amplitudes. म्हणजे सपोज याचा amplitude असेल a1, याचा amplitude असेल a2, then the resultant amplitude is the vector sum of the individual amplitudes. This is the principle of superposition of waves. Now, how to write this vector addition as resultant is equal to under root, you know this, a1 square plus a2 square, magnitude of first vector, the square, magnitude of second vector, the square, plus 2 into a1 a2 cos of angle between the two vectors. So a1 square plus a2 square plus 2 a1 a2 cos theta. ठीक है. So this is the principle of superposition of waves. Make a note or write the definition. Write this principle. When two waves meet at a point simultaneously, or two waves arrive at a point simultaneously, then the resultant amplitude, will be the vector sum of individual amplitudes. will be the vector sum of individual amplitudes. Okay. Now see, if these two, pause the video and write this. Okay. Now if these two waves are superimposed, then they interfere each other. बघा, दोन डिफरंट मेंटॅलिटीचे पर्सन्स आले तर ते एकत्र आले तर एकमेकांच्या लाईफमध्ये इंटरफिरन्स होऊ शकतो. सो सेम वे वेन टू वेव्स कम टुगेदर ते इंटरफिअर विथ इच अदर. मे बी ते दोन पर्सन एकमेकांना हेल्प करतील आणि दोघंही प्रोग्रेस करतील, डेव्हलपमेंट करतील, और एकमेकांना डिस्ट्रक्ट करतील. ठीक आहे. सो इंटरफरन्स is of two types. One is constructive interference and other one is destructive interference. So suppose in case of constructive, this is the amplitude A1 and another wave of amplitude A2. When these two waves superimpose each other, we'll get the resultant amplitude as this. Resultant amplitude will be A1 plus A2. Now here see, crest superimpose on crest, trough superimpose on trough. So crest plus crest will be the extra crest or more crest. Trough plus trough will be the some extra trough. So this is the A1 plus A2. This type of interference is constructive interference. So when crest is superimposed on crest or trough is superimposed on trough, then this kind of interference is constructive interference. Now suppose in this case, this is the wave of amplitude A1. When this superimpose on another wave, now here the amplitude is A2. Now see, in this case, the crest superimpose on trough and trough superimpose on crest. Now crest is positive and trough is negative. So here this A2 will be subtracted from this A1. This A1 is positive amplitude and A2 is negative amplitude. So here the positive plus negative will be the subtraction. And this kind of interference is called destructive interference. Here we get the shorter amplitude, smaller amplitude, and this will be A1 minus A2. So when crest superimpose on trough, so now here we can say the phase difference is 0. The phi is 0 because delta phi phase difference is 0. Because see, he wave and he wave दोन्ही पुढे पाठीमागे नाही आहेत. Neither of the two waves is lagging or nor is ahead of any wave. And here the second wave is lagging by 180 degree. See, 0, 90, 180. हा portion इकडे आलेला आहे. So 180. So delta phi in this case is 180 degree, or you can say pi radians. So these two kinds of interference are there: constructive and destructive interference. Pause the video in between and write everything. Now we'll see stationary waves. What is stationary wave? When two waves traveling in opposite direction, suppose the amplitude of this wave is A1, amplitude of this wave is A2, these are traveling in opposite direction. So I can write the equation of this wave as y is equal to A1 sine omega t. Now this is traveling in positive x direction, hence here it will be negative. A1 sine omega t minus kx, and this is traveling in negative x direction, hence here it will be plus sine positive kx. Now when these two waves superimpose each other, what will happen? See, and if we consider the amplitudes are same like A1 and A2, then what will happen? The resultant amplitude, the y, will be equal to y1 plus y2. Now this y is nothing but a. A is common. A is here as well as here also. A. So a is common from these two. So remaining terms will be sine omega t minus kx plus sine omega t plus kx. Okay. Now this is sine c plus sine d. So mathematics people, you know this sine c plus sine d is nothing but 2 sine c plus d by 2 cos c minus d by 2. So biology people, B group people, remember this. This is the first angle, this one is the second angle. So sine, this bracket is the first angle, this bracket is the second angle. So 2 sine addition of the two angles divided by 2 and subtraction of the two angles divided by 2. Here it will be sine and here it is cos. Now A. So this 2 will come here. 2a sine c plus d. C plus d. So when I add this to omega t plus omega t, it will be 2 omega t. Kx minus kx cancel each other. So this will be 2 omega t upon 2. जर समजलं असेल तर आपण असं करूया ओमेगा टी प्लस kx plus omega t minus kx, addition of this angle c plus d upon 2, kx minus kx cancel, cos c minus d. So omega t plus kx minus d, minus of this, so minus omega t plus kx. So see, when negative sign enters into this bracket, the positive term will get negative and the negative term will become positive. So it will become minus omega t plus kx. So minus omega t plus omega t cancel and upon 2, upon these two. Now see, omega t plus omega t, it will be twice of omega t. So we can say that y is equal to 2a sine 2 omega t upon 2 and cos 2 kx upon 2. See, kx plus kx, that is 2 kx upon 2. 2 and 2 will get cancelled, 2 and 2 will get cancelled. So the equation will become y is equal to 2a. I will bring this cos kx here, cos kx and into sine omega t. Now we will assume this 2a cos kx because any wave, equation of any wave is a amplitude into sine of omega t. So amplitude into sine of omega t. So sine of omega t is already present. So I will call the remaining term as the resultant amplitude. So y will be resultant amplitude r into sine omega t. Okay. So this is the equation of stationary waves, where the resultant amplitude, what we have assumed r is 2a cos kx. And for your information, see, as omega t is 2 pi, omega is 2 pi upon t, similarly k is 2 pi upon lambda. As omega is 2 pi upon t. So in one cycle, the angle is 2 pi and time required for this is t. Similarly, in one cycle, the distance covered is lambda. So, जसं मी आधी म्हटलं तुम्हाला की वेव ही डबल पिरियडिक असते, periodic in time as well as periodic in distance. So omega represents it is periodic in time, k represents it is periodic in distance. The time required to complete one cycle is time period and the distance covered in one cycle is wavelength. So that's why 1 cycle means 2 pi, so 2 pi upon time required and 2 pi upon distance covered. This is periodic in time and this one is periodic in distance. Okay. So you can also write this R as amplitude, resultant amplitude as 2a cos 2 pi by lambda into x. In place of k, we can write 2 pi upon lambda. So this is the derivation of stationary waves. Pause the video and write this. Now, based on this resultant, we get 2 points that are nodes and antinodes. Nodes are the point of minimum or zero amplitude. Okay. Points of zero or we can say minimum amplitude. जिथे amplitude minimum असतं अशा पॉइंटला काय म्हणतो आपण नोड्स म्हणणार आहे आणि अँटी नोड्स म्हणजे पॉइंट्स ऑफ मॅक्सिमम amplitude. आता ते कुठे येतात बघूया. Now the resultant, this R is 2a cos 2 pi by lambda x. Now this amplitude will become 0 if R is 0. That means 2a is constant, 2 is the number, amplitude is the constant. Then this cos 2 pi by lambda will be 0. That is cos of 2 pi by lambda x is 0. And cos ची value 0 कधी असते? Cos ची value 0 असते 90 degree, 270 degree. That is the odd multiple of 90. 190, 390, 3 into 90 is 270. So odd multiple of pi by 2. So you can say 2 pi by lambda into x is odd multiple of pi by 2. Odd multiple. So 2n minus 1 by 2n minus 1 into pi by 2. See, pi by 2 is 90 degree. And if I substitute n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, see. Now 2n, any number into 2. Any number into 2 will be an even number. If you multiply any number with 2, you will get an even number, and even number minus 1. Even number madhun jar 1 minus zala, then we will get an odd number. So this is odd number. Odd into pi by 2. Let's, for example, if I substitute 1. So 2 into 1 is 2. 2 minus 1 is 1. So 1 into pi by 2, that is the 90 degree. If I substitute 2. 2 into 2, 4. 4 minus 1, 3. 3 into this 90. 270 degree. So we are getting this value as 0 when this angle is 90, 270, then again 450, odd multiple. So pi and pi will get cancelled. From here we will get x is equal to 2n minus 1. This lambda will goes to numerator and this 2 will goes to denominator, and 2 and 2 will be 4. 2 into 2 will be 4. So it is the odd multiple of lambda by 4. Odd multiple of lambda by 4. So at the positions which are odd multiple of lambda by 4, there are the nodes. आपण बघणार आहे डायग्राम मध्ये काय असणार आहे. ठीक आहे. सो 45 डिग्रीच्या टर्म्स मध्ये ऑड वाल्या यू विल गेट नोड्स. नाउ antinodes. Antinodes means resultant is maximum, and maximum resultant occur when we get the maximum value of this cos. So maximum value of cos, you know that cos and sin having maximum value as 1. 1 or plus or minus 1. We can say plus or minus 1. So plus 1 is the maximum value in crest, minus 1 is the maximum value in trough. So when this happens when 0 degree, 180 degree. At 0 degree, cos 0 is 1. 180 degree, cos 180 degree, that is pi. Cos 180 degree is minus 1. Then cos 360 degree is again plus 1. So every multiple of 180 degree. So 0 means 1 into 180 degree. 180 means 1 into 180 degree. 360 means 2 into 180 degree. So integral multiple, we can say integral multiple. So 2 pi upon lambda into x is integral multiple, that is n into pi. So pi and pi will get cancelled. We'll get x is equal to n lambda. This lambda will go to numerator and 2 will goes to denominator. Integral multiple of n lambda by 2. So where n is equal to 0, 1, 2, 3, 4. If you want 0 over here, जर तुम्हाला इथं 0 हवा असेल, then you have to write plus 1 here. Because even minus 1 जसा ऑड आहे तसा even plus 1 सुद्धा ऑड असणार आहे. So if you want 0 over here, then write plus n. So these are the conditions of nodes and antinodes. मग आता बघूया, आता पाहिलं आपण की नोड्स कुठे येणार आहेत. x is equal to 2n minus 1 into lambda by 4. This is the condition for nodes, and for antinodes x is equal to n lambda upon 2. Okay, now see, any odd multiple of 45 degree is having node, and any multiple of lambda by 2 is antinode. Okay, now last point of this chapter, or second last point. आता हे सगळं बरंचसं बेसिक आपण बघितलंय, आणि मेन इम्पॉर्टंट पॉइंट राहतोय जो आपण एक्झामला विचारला होता, दॅट इज मोड्स ऑफ व्हायब्रेशन. Modes of vibration. So the first case आपण बघूया, modes of vibration of string wave fixed at both ends. Modes of vibration of string wave fixed at both ends. Let's see, is it visible or not? Now modes of vibration of string fixed at both ends. Now see, this is the suppose string which is fixed at both ends. Now लक्षात घ्या, जेव्हा इथे फिक्स असते, एखादी स्ट्रिंग आपण घेतली आणि स्ट्रिंग जर एका ठिकाणी आपण इथं टाय केलेली आहे, बांधलेली आहे, तर इथला जो पॉइंट आहे तो वरती खाली जाणार नाही, तो व्हायब्रेट होणार नाही, तर तिथं आपण टाय केलेली आहे. सो त्याचा ॲम्प्लिट्यूड कधी पण काय असणार आहे, 0 असणार आहे. सो वी कॉल्ड इट ॲज नोड, जे आपण नोड पाहिलेलं आहे. सो इथे एक नोड असणार आहे आणि इथे एक नोड असणार आहे, कारण दोन्ही साईडला फिक्स केलेलं आहे. सो पहिली केस अशी होऊ शकते की दोन नोडच्या मध्ये अँटी नोड आला, म्हणजे फॉर एक्झाम्पल इथं क्रेस्ट बनलेला आहे, हा क्रेस्ट बनलेला आहे, म्हणजे इथं वरती खाली व्हायब्रेट होईल. दिस इज द पॉझिटिव्ह अँप्लिट्यूड, दिस वन इज द निगेटिव्ह अँप्लिट्यूड. सो ही एक केस होऊ शकते की बिटवीन द टू नोड्स देयर इज अ antinode. So what we can say, now suppose this is the length L, this is the length L of string. Now see, when I want to complete this wave, this will be the complete wave, and this distance is called lambda. This total distance is lambda. Now out of this lambda, this is the half portion, so we can call it as lambda upon 2. This is lambda upon 2 because this is only half wave, only crest is here. And after completing this trough, the wave is complete. So total this distance is lambda, then this L will be the lambda by 2. And from here, this lambda will be 2L. Lambda is 2L. Now, one more thing. Make separate note that, see, velocity is distance upon time. Okay, distance upon time. Now, distance. To complete one wave, the distance traveled is the wavelength. So, I can write this as wavelength. And time, to complete one wave, we require complete time period, that is capital T. So 1 upon T, when this time goes to numerator, we can write it as frequency because reciprocal of time is frequency. So 1 upon time is nothing but frequency. So velocity is lambda into frequency mu. Okay. Or you can write n, lambda into n. So from here, this n is equal to velocity upon lambda. Velocity upon lambda. This frequency is velocity upon lambda. See, once again, velocity is distance upon time. Distance can be written as distance covered in one cycle. Time is time period, time required for one cycle. So distance covered in one cycle is lambda, that is wavelength, and time period is t. Now reciprocal of this time is frequency, mu, n. Okay. Now from here the frequency is velocity upon lambda. This lambda is in numerator. When it goes to other side, it will be velocity upon lambda. So velocity upon lambda is the frequency. So we can calculate the frequency of this wave here as it is velocity upon lambda. Okay. So velocity we have seen, that is velocity is t by mu. And in place of this lambda, we can write, this is the velocity upon lambda. In place of lambda, we can write 2L. So 1 upon 2L root of t by mu. This is called fundamental frequency. This is called fundamental frequency. Fundamental frequency or zeroth overtone. Zeroth overtone. As here it is written 1, we can call it as first harmonic. See, fundamental frequency or first harmonic. First harmonic असेल तर overtone 0 असणार आहे. ठीक आहे. सपोज सेकंड हार्मोनिक असेल तर तो फर्स्ट ओव्हरटोन असणार आहे. सो फर्स्ट हार्मोनिक आहे तर झिरोथ ओव्हरटोन. झिरोथ ओव्हरटोन. नाउ सेकंड केस बघूया आपण. केस 2. दिस इज द केस 1. केस 2. सपोज इथे एक नोड आहे, मध्ये क्रेस्ट आला, आणि इथे परत नोड आला. म्हणजे दोन नोडच्या मध्ये दोन अँटी नोड पण आले आणि एक नोड पण आलेला आहे. सो हियर सी दिस कंप्लीट लेंथ L of the string is nothing but wavelength. Length of the string is nothing but wavelength because this is the complete wave. Here the wave is half, hence the length of string is nothing but wavelength upon 2, half of the wavelength. But in this case, the complete length of the string is nothing but wavelength. So in place of this lambda, we can write L. Now see, frequency, आत्ताच आपण पाहिलं, frequency is velocity upon lambda. This velocity is nothing but under root t by mu, and this lambda is nothing but L. Now to compare with this, याच्यासोबत कंपेअर करता इथं 2L आहे, अंडर रूट t by mu आहे. इथं 1/L आहे, इथं 2L नाही आहे, पण √T/L तर आहे. मग T/μ तर आहे. मग मी काय करणार, इथं 2 लिहिणार आणि इथं पण 2 लिहिणार. सो 2/2L √T/μ. नाऊ वी कॅन कम्पेअर. का कम्पेअर करू शकतो? रूट मध्ये T/μ आहे, इथं पण रूट मध्ये T/μ आहे, इथं पण 2L आहे, इथं पण 2L आहे. डिफरन्स काय आहे? इथं 1 आहे आणि इथं 2 आहे. इतका डिफरन्स आहे. मग इथं जर याला फर्स्ट हार्मोनिक म्हणतोय, त्याला आपण सेकंड हार्मोनिक म्हणतो. सो हार्मोनिक, दिस नंबर, इथं जो नंबर असेल दॅट विल रिप्रेझेंट द हार्मोनिक. ओव्हरटोन त्याच्यापेक्षा एक ना कमी असणार आहे. सो वी कॅन कॉल इट ॲज सेकंड हार्मोनिक. सेकंड हार्मोनिक or first overtone. Second harmonic or first overtone. One second. Now the third case, case 3. Now between the two nodes there are three antinodes. This is the first antinode, second antinode, and this one is the third antinode. And this is the node 1 and node 2. And these two are the fixed point, that are the nodes. So how many waves are there in one complete length of the string? Now see, this is the complete length, complete wavelength, and this one is the half. So this is 3/2 or 1.5 the wavelength. So you can see, we can say this length L is nothing but 3/2 of the wavelength. 3/2 of the wavelength. 3/2 म्हणजे काय? एक wavelength plus half. 1 plus half. See, this is one complete wave plus half. Okay, another remaining half is here. So 2 1 are 2, 2 plus 1, 3/2. So from here lambda is equal to 2L/3. 2L upon 3. This 2 goes to numerator and 3 will be in the denominator. So this lambda is 2L/3. Now what is the formula? Frequency is velocity upon lambda. Okay, lambda is 2L/3. So in place of lambda we can write 2L upon 3. The upon 3 will go to numerator. Okay, and velocity is under root T/μ. Now see, when you compare this with the first, in place of this 3 there is 1, here it is 3, so we can call it as third harmonic. Third harmonic or second overtone. Third harmonic or second overtone. So these are the cases of modes of vibration of string wave fixed at both ends. Now write everything. आता इथं बघूया, fixed at one end. Fixed at one end. Next, modes of vibration of string wave fixed at one end. Fixed at one end means ultimately free at other end. Fixed at one end म्हणजे काय? Free at other end. So now any string when it is free at other end, fix असेल तर तिथं नोड असणार आहे, फिक्स असेल तर नोड असणार आहे, पण फ्री असेल तर तिथं ती काय होऊ शकते, व्हायब्रेट होऊ शकते, तिथं नोड नाही बनणार, तिथं अँटी नोड बनणार आहे. सो इथं समजा आता आपण काय केलं, एक इथं मी रस्सी पकडली हातात, एका साईडला टाय केली इकडं आणि दुसऱ्या साईडला एक बार ठेवला, एक रॉड ठेवला, रॉडमध्ये एक रिंग घातली, रिंग म्हणजे अंगठी टाईपची रिंग, आणि त्याला जर रस्सी बांधली तर ती रिंग काय होणार आहे, स्लाइड होणार आहे त्या रॉडवरती, म्हणजे तिथं ॲम्प्लिट्यूड्स असणार आहेत, व्हायब्रेशन्स येणार आहेत. पण या साईडला काय होणार आहे, ऑसिलेशन येणार नाही. इथं आपण फिक्स केले तर नोड, इथं फिक्स नाही आहे तर अँटी नोड. द फर्स्ट केस हिअर इट इज नोड अँड हिअर इट इज अँटी नोड. म्हणजे इथं जाऊन काय करणार आहे, क्रेस्ट बघेल. सो वी कॅन से this is L is lambda upon 4. This length is lambda upon 4 because see this is 1/4. अजून crest complete व्हायचं आहे. Now this is the half wave. याच्यानंतर this is the full wave. So या फुलच्या इथपर्यंत हाफच्या पण हाफ, that is lambda by 4. हाफच्या पण अर्धी. So 1/4 आहे ही wave. So from here see lambda is 4L. This lambda 4 goes to numerator 4L. We know that frequency or n frequency is velocity upon lambda. In place of lambda we can write 4L and the velocity is under root t by mu. Under root t by mu. So this is the frequency 1 upon 4L under root t by mu. Now here it is 1, hence it is called first harmonic. पहिलीच आहे म्हणून फंडामेंटल फ्रिक्वेन्सी अँड पहिला आहे विथ द झिरोथ ओव्हरटोन. नाउ सेकंड केस, केस 2. केस 2 इथं आहे ना एक वेव कंप्लीट केलेली आहे. सो एक वेव कंप्लीट करायला अजून पाव बाकी आहे. इथं गेल्यानंतर एक वेव कंप्लीट होईल अशी. Okay, so half plus lambda by 4. So this is 3/4. This is 3/4. So this L is 3/4 of lambda. L is 3/4 of lambda. Half plus 1/4. 50 plus 25. That is 75. 3/4. And from here lambda is 4L by 3. So the frequency is velocity upon lambda. This lambda is 4L by 3. So 1 upon 4L upon 3, 4L upon 3 will come to numerator. So 3 upon 4L under root velocity is under root t by mu. So this frequency is 3 upon 4L, or you can write here 1 upon 4L by 3. This 3 comes to numerator. 3 upon 4L under root t by mu. Now see, compare this to 4L and 4L are present, root are there. So in place of 1 here it is 3, then it is called third harmonic. Okay, and overtone is the first overtone because this is the zeroth overtone, this is the first overtone, this one will be the second overtone. So always remember, overtones are like, for the first harmonic it is zeroth overtone. For any second one, higher frequency, it will be second overtone. For any higher first overtone, and for any higher frequency, it will be the second overtone. But the harmonic number is represented by this 1, 3. इथं काय येईल आता, ठीक आहे. So overtone चे number तर fix झाले, zeroth overtone, first overtone, second overtone. But frequent harmonic number is represented by the number in the numerator. Now we'll see case 3. Now here see, one complete wave and 1/4. That means lambda plus lambda by 4. 4 1s are 4, 4 plus 1 5. So it is 5 lambda by 4. 5 lambda by 4. One complete wave plus 1/4. So we can write this length as 5 lambda by 4. So from here lambda is 4 goes to numerator, 5 goes to denominator. 4L by 5. 4L by 5. So from the formula, n is equal to velocity upon lambda. So 1 upon 4L by 5. This 5 goes to numerator. This 5 goes to numerator here upon into root t by mu. Now when you compare this 1, 3 and here it is 5. So we can call this as fifth harmonic. we can call this as fifth harmonic and the second overtone. So the overtone number is always 0 overtone, first overtone, second overtone, but the harmonic number is represented by this number: first overtone, the first harmonic, third harmonic, and fifth harmonic. So in the case when the string is fixed at both ends, the ratio of the harmonics is 1:2:3. But in the case of string fixed at one end or free at one end, the ratio is 1:3:5. So 1:2:3. This is when string fixed at both ends, and 1:3:5 when the string fixed at one end, or we can say free at one end. Okay. So these are the two cases, two modes of vibration. Of string wave. Now similarly, we are going to see modes of vibration of air column. So air column means modes of vibration of sound wave. So modes of vibration of air column with both ends open. With both ends open. So एअर कॉलम म्हणजे आता समजा बासरी असते, ठीक आहे, गिटार आहे, गिटारचं कसं असतं, एक होल असतं. आता कन्व्हेन्शनल गिटार, आत्ताचे इलेक्ट्रॉनिक गिटार्स नव्हे, जुने कन्व्हेन्शनल गिटार्स जे होते तर काय होतं की तिथे एक होल असायचं आणि बॅक साईडला पेटी, किंवा हार्मोनियम असेल तर पुढं 5 होल असतात. सो वन साईडला ओपन असतं, दुसऱ्या साईडला क्लोज असतं. सो इथं आपण पहिला बघा एअर कॉलम म्हणजे बासरी टाईपचं की दोन्ही साईडला ओपन आहे. सो अशा केसमध्ये बोथ एंड्समध्ये ओपन असेल तर काय होणार आहे. सो केस 1, जर ही बोथ साईडला ओपन असेल अशी, तर पहिल्यांदा इथं अँटीनोड असणार आहे, मध्ये नोड असेल, परत इकडे अँटीनोड असणार आहे. म्हणजे इकडं 1/4 आहे, इकडं 1/4 आहे. बघा ही जर वेव्ह इथं आपण पुट केली तर हाफ होते. सो दिस इज हाफ. दिस लेंथ इज लॅम्बडा अपॉन 2. सो फ्रॉम हियर lambda is 2L. Now the frequency is velocity upon lambda. Okay, lambda is 2L, so the frequency will be n is 1 upon 2L, and velocity in sound wave is p by rho. Velocity in case of sound wave is p by rho. So this is called fundamental frequency or first harmonic, because here it is 1 first harmonic and 0th overtone. Fundamental frequency, first harmonic and 0th overtone. After each case you have to write these conclusions. Okay, now case 2. Now see here, this is 1/4, this one is 1/4, and this is half. Half plus 1/4, 3/4, 3/4 plus 1/4 is complete wave. So this complete length of the air column is the length of the wave, that is the wavelength lambda. Now the frequency is velocity upon lambda. Lambda is nothing but L, velocity is nothing but p by rho. To compare with this, here it is 2L, but here it is only L. So I have to write 2 in the numerator as well as 2 in the denominator. It will be 2 upon 2L under root p by rho. Now we can say, if we compare these two, here it is 1, here it is second, then I have to write here second harmonic. As this is 0th overtone, this is the first overtone, but here it is 1, that's why this is first harmonic, here it is 2, That's why it will be second harmonic. Now case 3. Now see here from here, one trough is there, one crest is there. This half plus this half is full wave. This 1/4 and this 1/4. This 1/4 and 1/4 is half. So half plus half, 1 plus half, 3/2. So did wave आएगी did. So you can say L is 3 lambda by 2. 3 lambda upon 2. From here lambda is 12 by 3. Lambda is 12 by 3. Now the frequency is V, velocity upon lambda. Velocity upon lambda. So 1 upon lambda means 12 by 3. 1 upon lambda and root P by rho. Now when this 3 goes to numerator, it will become 3 upon 12 root of P by rho. Now compare this number. Here it is 1, here it is 2, in this case it is 3. So we can say it is third harmonic. Third harmonic. And same as this is 0th overtone, first overtone, second overtone. So overtone number is same always, 0th overtone, first overtone, second overtone, but harmonic number is represented by the number in the numerator. So this one is first harmonic, this one is second harmonic, and this one is the third harmonic. Now pause the video and write everything. आता इथे काय होतं, मोड्स ऑफ व्हायब्रेशन ऑफ एअर कॉलम विथ बोथ एंड्स ओपन. नाव इथे आपण दुसरी केस बघणार आहे विथ वन एंड क्लोज. विथ वन एंड क्लोज, एक एंड क्लोज असेल अशा एअर कॉलमचे व्हायब्रेशन्स बघणार आहे. एक एंड क्लोज असणार आहे म्हणजे आता इथे असा क्लोज असेल. मग क्लोज असेल तर तिथे काय बनणार आहे, नोड बनणार आहे. ठीक आहे, नोड असणार आहे. मग नोड असेल आणि इकडे काय असणार आहे, अँटी नोड असणार आहे. मग हे किती झालं बघा, 1/4 आहे. कारण हे एक क्रेस्ट फक्त क्रेस्ट पर्यंत आली पण खाली नाही गेली परत, म्हणजे मीन पोझिशनला नाही गेली. ट्रफ तर दूरची गोष्ट, पण सो वी कॅन से दिस कंप्लीट लेंथ ऑफ ट्यूब इज नथिंग बट लॅम्बडा बाय 4. फ्रॉम हियर लॅम्बडा इज 4L. Lambda is 4L. Now the frequency is velocity upon lambda. So we can say velocity is under root P by rho and 1 by lambda. Lambda is nothing but 4L. So this frequency is 1 by 4L P by rho. This is the fundamental frequency. In the numerator here it is 1, so it is first harmonic and the 0th overtone. Now see the case 2. Case 2, again at closed end, here the node should be there, one complete crest, and here the half negative wave. Now tell me, what is the length of air column? Length of air column is 3/4 of the wavelength. Why 3/4? This is half and this is 1/4. Half and 1/4 is half and 1/4 is 3/4. So you can say L is 3/4 of lambda. So from here lambda is 4L by 3, 4L upon 3. So frequency is equal to velocity upon lambda. Velocity is under root P by rho and lambda is 4L by 3. So when this 3 goes to numerator, it will be 3 upon 4L under root P by rho. Now tell me, here it is 4L, here also 4L, but here it is 1, but here in the numerator it is 3, so this is called third harmonic. Third harmonic. Okay, now come to case 3. Now see, one complete wave plus 1/4. Complete wave plus 1/4 means lambda plus lambda by 4. 4 on the 4, 4 plus 1, 5 lambda by 4. So this length is L is equal to 5 lambda by 4. From here lambda is 4L by 5. Lambda is 4L by 5. So frequency will be equal to velocity upon lambda. So velocity is, first of all, 1 upon lambda. 1 upon lambda is 1 upon 4L by 5. Velocity is p by rho. This 5 goes to numerator. And the frequency is 5 upon 4L root of p by rho. And when you compare this 1, 3 and here it is 5, then it is called fifth harmonic. Fifth harmonic and second overtone. So these are the 3 cases, 4 cases we have seen, 4 modes of vibration. First is vibration of string wave closed at or fixed at both ends, vibration of string wave free at one end, then vibration of air column open at both ends, and vibration of air column open at one end is closed and one end is open. Now this is the end of the chapter, and the one point is remaining. Even at the day of annual exam, I have told you that what is forced vibration and free vibration. So any simple pendulum, if you keep that on natural oscillations, then it is called free vibration. Any pendulum आहे त्याला तुम्ही डिस्टर्ब केला आणि सोडलात तो व्हायब्रेट होत राहील, देन इट इज फ्री व्हायब्रेशन. बट एक जर बॉल तुम्ही घेतलात क्रिकेटचा आणि त्याला लटकवलात आणि कंटिन्यू बॅटने हिट करत राहिलात, सो द ॲम्प्लिट्यूड विल नॉट डिक्रीज. ते डिक्रीज होणार नाही, त्याचं कसं एनर्जीचा लॉस होईल तेव्हा तुम्ही परत इम्पॅक्ट देणार आहे. दॅट इज फोर्स्ड व्हायब्रेशन. देन व्हॉट इज द रेझोनन्स. एक क्वेश्चन होता ॲन्युअल एक्झामला, द रेझोनन्स. अँड वन मोर क्वेश्चन इज वाय मिलिटरी परेड is not allowed on the bridge. ब्रिज जे असतात, पूल, नदीचा ब्रिज असतो ना, रिव्हरवरती जो ब्रिज असतो, रेल्वेचा ब्रिज असेल किंवा रोडवेजचा ब्रिज असेल, तर का मिलिटरीचं परेड अलाउड नसतं. सो द रेझोनन्स मीन्स इज द कंडिशन ऑफ, इट इज अ फ्रिक्वेन्सी ॲट विच द ॲम्प्लिट्यूड इज मॅक्सिमम. फ्रिक्वेन्सी ॲट विच ॲम्प्लिट्यूड इज मॅक्सिमम, or if the frequency of disturbing wave matches with the frequency of the wave, then the resultant amplitude will be the maximum. The frequency जर मॅच होत असेल तर काय होतं, amplitude हे मॅक्सिमम होतं आहे. इन दॅट केस द ब्रिज मे फेल. लाईक सी, पहिला जो हिट बसणार आहे परेड करताना मिलिटरीचा, जो पहिला सर्वांचा, सगळे परेडमध्ये 100 लोकांचा तरी असणार आहे, ठीक आहे, किंवा 50 लोकांचा असेल, आणि ते काही नॉर्मल तुमच्यासारखं परेड करत नाहीत, खूप वरून पाय घेऊन जोरात हिट करतात, सगळ्यांचे ॲट अ टाईम हिट बसणार. नाव तो हिट बसला तर त्यावेळी ब्रिज काय व्हायला लागणार आहे, व्हायब्रेट होऊ लागणार आहे. म्हणजे ब्रिजची पण काहीतरी फ्रिक्वेन्सी असणार, त्या फ्रिक्वेन्सीने तो व्हायब्रेट होतो. तो व्हायब्रेट होतोय त्याच वेळी सेकंड दुसरा बीट पडणार, दुसरा बीट परेडचा परत आणखीन एक लेग हे करणार. मग जर ब्रिजच्या व्हायब्रेशनची फ्रिक्वेन्सी आणि सोल्जर्स किंवा जे मिलिटरी पर्सन्स आहेत त्यांच्या परेडची फ्रिक्वेन्सी जर मॅच झाली, देन द ब्रिज विल ऑसिलेट विथ द मॅक्सिमम ॲम्प्लिट्यूड. आता ते ॲम्प्लिट्यूड आपल्याला दिसत नाही, पण ते खूप मायन्यूट ॲम्प्लिट्यूड्स असतात, ठीक आहे. कॉन्क्रीटचे ब्रिज असतात त्यामध्ये आपल्याला दिसत नाहीत, मायन्यूट ॲम्प्लिट्यूड असतात, त्या ॲम्प्लिट्यूडनं तो व्हायब्रेट होणार आहे. वेन द फ्रिक्वेन्सी मॅचेस फ्रिक्वेन्सी ऑफ द व्हायब्रेशन ऑफ bridge and frequency of the military persons or that soldiers, then the resonance, condition of resonance will occur. And condition of resonance means maximum frequency at which the amplitude is maximum, and in that case the bridge may get cracked. तो क्रॅक होऊ शकतो, तो फेल होऊ शकतो, ठीक आहे ना, फॉल होऊ शकतो. सो दिस कंडिशन इज कॉल्ड रेझोनन्स. दॅट्स वाय द मिलिटरी परेड हॅज टू स्टॉप वेन दे अराइव्ह ॲट ब्रिज. ब्रिजवर आल्यानंतर त्यांना नॉर्मली चालत जावं लागतं आणि तिथून पुढं परत त्यांचं परेड स्टार्ट होतं. सो दिस इज द रिझन. सो with this we have completed the syllabus of 11th standard part 2. Okay, somebody asked me about heat and calorimetry. So heat and calorimetry I have covered. That is calorimeter is the device used to measure the energy heat. A unit of heat is joule, earth, and calorie. Calorie conversion तर मी तुम्हाला सांगितलं 4.2. एक क्वेश्चन पण होता टेस्टला. Then what is the specific heat? I told you specific heat CP आपण पाहिलेली आहे. Then specific heat CV, this is the specific heat at constant pressure, specific heat at constant volume. Then what is the latent heat? Latent heat, now specific heat is the heat required to raise the temperature of any body by 1 degree Celsius. 1 kg च्या कुठल्याही बॉडीचं टेम्परेचर 1 degree Celsius न वाढवायचं असेल तर त्याला स्पेसिफिक हीट म्हणतात. तर what is the latent heat? Latent heat you have studied in 8, 9, 10 classes. Latent heat of vaporization, latent heat of freezing, latent heat of sublimation. So the heat required to convert 1 kg of ice into water is called latent heat of condensation असेल, किंवा to convert 1 kg of water into ice is the latent heat of freezing आहे. ठीक आहे. सो कन्व्हर्जनसाठी जी हीट लागते एका फॉर्ममधून दुसऱ्या फॉर्ममध्ये, हे तुम्ही पाहिलेलं लॅटेंट हीट. सो with this again we have seen the law of mixture. When two substances mix together, temperature of one substance will decrease and temperature of other substance will increase. Again this is the part of heat and calorimetry. So that chapter is covered. So with this and most of the numericals, like see papers from papers design, question papers of our weekly test designed by Gupta sir, Sen Gupta sir, as well as papers designed by me, the both in weekly test papers I have discussed, and the most of the problems of that weekly test papers are from Cengage itself. So by this most of the part of our Cengage आपण डिस्कस केलं आहे. रिमेनिंग पार्ट डिस्कस करणारच आहोत, पण असं काही नाही की तुमचे MCQs डिस्कस केलेले नाही आहेत. ठीक आहे. कम्पेअर टू अदर सब्जेक्ट्स वी हॅव डिस्कस अलॉट. ठीक आहे. माझे पण मी डिस्कस करतच होतो, प्लस गुप्ता सरांचे पण डिस्कस करतच होतो. ठीक आहे. तर स्टे सेफ, स्टे हेल्दी. इफ यू हॅव एनी डाऊट प्लीज कॉल मी और मेसेज मी ऑन माय पर्सनल नंबर, व्हॉट्सॲप नंबर. आणि याचा जो आहे ज्या शिकवले त्याचं नोट्स बनवायचे आणि मला त्याची PDF करून तुम्ही व्हॉट्सॲपवरती सेंड करा. ठीक आहे. ओके.